On April 20th, 2010, the United States experienced the largest offshore oil spill in its history. To discover the impact of the blowout, scientists from around the world converged on the Gulf of Mexico.
It's one of the first oil spills where enough resources have been put aside to study it for 10 years after the spill.
Why are so many dolphins in the Gulf of Mexico losing their young? Why are so many pregnancies failing?
I'm using DNA barcoding to look at gut contents of unidentifiable fish. I guess I'm a fish detective.
This is really the first step in making the marine snow. When we started this, we didn't know it was going to work as well as it has worked.
We have the ability to produce the same conditions in this laboratory that are in the deep sea. It's like sitting on the floor of the ocean and watching the droplets and bubbles that are rising under these extreme conditions.
The purpose of our cruise here is to look at how oil might spread in a future oil spill.
There'll be 2 ships, 3 planes, and they need to be coordinated.
We're going to get bounced around a little bit. 230.
Our research group studies the cardiac impacts of oil on fish, especially looking at the heart.
There we go. This is what we live for, what we work for, all the time spent behind the computer.
Biopsy.
We only do that really so we can get out here.
Look at her, she's gonna swim right off.
It's really exciting to see how all the pieces come together, where all these different people are involved in all these components.
Today, an international team of researchers are focused on the Gulf of Mexico. These are some of their stories. Intimate portraits of research, innovation, discovery. We begin here, about 60 miles south of New Orleans, as first light touches the salt marshes and shallow waters of Louisiana's Barataria Bay. Protected from the open waters of the Gulf of Mexico by a chain of barrier islands, 200 years ago, these coves and bayous were home to marauding bands of pirates. Though the pirates are long gone, the bay remains a popular stopover for tens of millions of migratory waterfowl. Its marshes and mangroves are fertile nesting grounds and nurseries for birds and fish. And despite being hit hard by the 2010 oil spill, these waters teem with hundreds of species of marine animals. This is also the permanent home for about 1,300 bottlenose dolphins. Though the acute health effects of the oil spill are over, a team of scientists are searching for answers to a surprising discovery. Their investigation begins here, almost 2,000 miles from the waters of Barataria Bay, at a military base in San Diego, California. This is home to over 70 bottlenose dolphins that are part of the Navy Marine Mammal program. Trained to work in open waters, one of their missions is to use their sonar skills to detect enemy threats, like sea mines. Cynthia Smith is director of the National Marine Mammal Foundation. She and her team are responsible for the health care of the dolphins.
Every day when we show up to work, we make sure that we're doing everything we can to provide them the best possible care. And part of that is this relationship that develops between our animal care experts and the animals. Well, what you're seeing here are my colleagues working one-on-one, a trainer with an animal, on their daily physical exam.
Right now we're working with our youngest calf. She's about 6 weeks old, and this is around the time when they start mouthing. We try to take an opportunity at this point to put fish in their mouth so that it's nutritious and it's good for them. Just like us, dolphins get bacteria in their mouths and on their teeth. And to make sure that their teeth are healthy and their gums are healthy, we brush their teeth daily. And as you can see, we try to make it as relaxing as possible.
But what exactly is the connection between the Navy dolphins and the dolphins of Barataria Bay? Simply put, these are among the healthiest bottlenose dolphins in the world. A perfect control group for scientists to measure the impact of oil on the bottlenose dolphins of Barataria Bay.
Hi, lady. Are you ready?
Forrest Gomez is Deputy Director of Medicine.
So, remind me what her recent history has been.
Her care of the dolphins includes monitoring their reproductive health, including periodic sonograms.
Dolphins do tend to get pregnant more on the left side, which is why we always check the left first. Let's go ahead and decrease the depth. That's good. Let's take that and save that. So far, not too exciting, but we'll check her again in a couple weeks because you never know. And then we're also following her with blood work, watching her progesterone really closely.
Pretty much every day we've been training for what's happening in the Gulf of Mexico. Those dolphins have been affected by the Deepwater Horizon oil spill, and the only way to really understand that is to study animals like this that are healthy and in good shape. When we go to the Gulf of Mexico, we're interested in why are so many dolphins losing their young? Why are so many pregnancies failing?
Three weeks later, Cynthia Smith and her team from the Navy Dolphin Program gather at a marina on Grand Isle, Louisiana, a slender barrier island protecting Barataria Bay. They have joined a team of NOAA veterinarians, biologists, and wildlife epidemiologists participating in a 10-day mission to evaluate the health of the local bottlenose dolphins.
We're already seeing health conditions that are concerning. We are also seeing pregnant dolphins, which is really important and good to document how those fetuses are doing and how the dams are doing.
Thanks everyone again. Welcome to Second Tuesday.
The morning briefing is led by Eric Zollman, a biologist from the National Ocean Service in Charleston, South Carolina.
I think we're going to try, where we were last week. There's always plenty of dolphins, sometimes too many. I'm the capture lead for this research project, which basically entails leading the project in the field when we're out on the boats, catching the dolphins. It's my decision which dolphins to concentrate on, which ones to target, and then which ones to ultimately set the net on and safely handle and get them to the hands of the veterinarians and the trained staff who can then do the actual science of what we're doing out here.
Just after sunrise, a fleet of 8 small boats with nearly 60 scientists aboard enter Barataria Bay. With temperatures expected to be in the mid-90s, it will be a very long, hot day on the water.
Oh, 3 of them.
It doesn't take long before dolphins surround the boats.
One of them split off.
These are year-round residents who rarely leave the bay. This is why they suffered during the 2010 oil spill. Their feeding behavior was adapted to this specific area, so when the oil entered the bay, they stayed, rather than move into safer but unfamiliar waters.
What we're looking to get is small numbers, 1, 2, or 3 animals in workable waters, which is anything less than 5 feet in depth.
Roaring hard.
4.
We've got a blue tag with 2 or 3 animals coming your way, Eric.
Copy that. Yeah, I just picked them up at my 12 o'clock. I see them. If we find such a group, we'll call in the catch boat with a 400-yard long net on the back of his boat. And we'll set a compass, basically just a big circle around those dolphins.
Yeah, I got about 3.5 on my sounder.
There's 123 in the net. We have 2 in the net.
2 in the net.
We've got about 15 to 20 experienced animal handlers who will then put in the water and space them evenly around the compass and induce the animals to hit, ideally in a location that we choose.
Go forward. Forward.
The dolphin hits the net. Typically, when they encounter that net, they'll spin on their long axis, which wraps them up in the net, which is actually a good thing for us because that slows them down. We'll let the net do its work, and then we get the handlers in there to support the animal and get them to the hands of the veterinarians and the trained staff who can then do the actual science of what we're doing out here.
Each dolphin receives a thorough examination, not unlike what was done back in San Diego. The major difference is that here, the goal is to discover any chronic health issues linked to oil exposure.
You guys okay? Can we do a capnograph? Yeah. Yeah? Okay. You guys can go ahead and come in and do that.
And because dolphins are mammals and breathe through their blowhole, monitoring their respiration will help the veterinarians decide whether their lungs are healthy or diseased.
48.
Blood samples are drawn from tail fins to screen red and white blood cells and to check for any abnormalities with their immune system.
Those are your last 2.
Biopsies are also taken for indications of problems with their reproductive hormones and the presence of pollutants. The samples are immediately brought to the team's floating laboratory. A team of biologists analyze and process them. At the end of the day, they're sent to scientists around the country for further analysis. Occasionally, the team captures a mother and her calf. When this happens, the animals are positioned facing each other, so they're never out of sight. This calms them down and allows the dolphins to verbally communicate with each other. The mother is on the right, and her very vocal 2-year-old calf is on the left.
Pregnant? First trimester.
During a routine sonogram, Cynthia Smith discovers that the mother, marked as YK5, is in the first trimester of pregnancy.
I'm just going to try to get a still of the eye.
To help the team track her location during the pregnancy, they attach a satellite tag to her dorsal fin. Her calf also gets a full physical, including dental x-rays. Before they're released, mother and calf are weighed. This is the first time they have ever been separated. The calf is clearly unhappy.
74.6. Coming down.
A few minutes later, they are reunited and released. During the 2-week research mission, the team examined 38 dolphins. Their preliminary findings are troubling. The scientists discovered that the dolphin population declined from 2,300 before the oil spill to 1,300 today. Many are underweight and in poor health. And because their reproduction rate is low, 21% as opposed to 65% in the wild, Cynthia Smith worries about the future of this dolphin population.
Transgenerational issues are still a big question, and that is something we're worried about. Are these dolphins going to pass those issues on to their offspring?
About 10 miles west of Grand Isle, scientists from Louisiana State University are heading to one of their key research sites. The goal is to monitor the condition of Louisiana's marshes. What they soon discover may also shed light on the health of the dolphins.
Got it.
Okay, put once you tie us off.
Ed Overton is the lead scientist.
What happened to the coastal marshes after the spill occurred is a story of good news and bad news. The beach is pretty solid ground, and so you can put heavy equipment on that beach and scrape the oil up and clean it up, and you haven't caused a great deal of ecological damage. But when oil comes on a coastal marsh, the marsh is not very solid. If you put heavy equipment on, it tears up the marsh and it pushes the oil down into the marsh. One of the things you never ever want to do is let oil get down below the surface. And so when it comes on a coastal marsh, we can't easily clean it up.
The good news is that the marshes are recovering.
This area was covered with oil, and now it's starting to return. There's essentially not significant amounts of oil still left on the surface. However, recently we've discovered that a significant amount has been buried along the beach. It looks like some of the oil flowed down at low tide into the crab burrows and stuck there. And so our current effort is focused on trying to find the buried oil and how much is there. Once oil gets below the surface, it stays down there. It doesn't get released all at once. It gets released a little bit at a time.
And here's where things get a little complicated.
At the edge of the marsh, what you're standing on now, is literally the nursery ground for the northern Gulf of Mexico fisheries. It's a protected area for small minnows and other little critters.
But these marshes are also a favorite feeding ground for the bottlenose dolphins of Barataria Bay. This raises the question, could the slowly leaking oil along the edge of the marshes be a clue in the mystery of their failing reproductive health?
This story is going to play out for many years, and it will take constant monitoring of these populations to really understand what was the long-term impact of this spill on dolphins living in the Gulf.
Dolphins are not the only animals affected by the spill. At the epicenter of that story is a place we fondly call the Big Easy. New Orleans is a city defined by Mardi Gras, jazz, and oysters. Lots of oysters. But during the stillness of early morning, New Orleans looks and feels different. More like a sleepy southern town. At least until you arrive at a small warehouse tucked away on a quiet street in the French Quarter. The P&J Oyster Company was founded in 1876 and is the oldest continuously operating oyster business in the United States. In 2010, just before the oil spill, P&J's workday usually began at 5 a.m. Today, things are different.
We usually shuck on average maybe 1 day a week now. We used to sell about 15 to 20,000 pounds of oysters in the shell a day that went to oyster bars in and around the country. And we don't do that anymore. We're trying to do our best to maintain our business, and we don't want to see it go down under our tenure.
For over 150 years, Louisiana was the nation's largest source of oysters. Thanks to a perfect combination of brackish and warm water, each day thousands of tons of oysters were harvested, loaded onto barges, and sent to New Orleans and on to cities around the country. By 2010, Louisiana supplied nearly 42% of the nation's oysters. But then the Deepwater Horizon blowout happened. Emergency crews did everything possible to protect coastal beaches and marshes. To break up as much oil as possible, dispersants were sprayed onto oil slicks on the surface of the water as well as directly into the escaping oil. After much debate, massive amounts of fresh water from the Mississippi River were released into the Gulf. At locations all along the lower Mississippi River, giant valves and floodgates were opened. And for 3 weeks, the Louisiana Delta became a freshwater estuary. The hope was that the freshwater release would push the oil away from the coast. But in the end, nothing could stop the advancing oil. Ultimately, the oyster beds of Louisiana suffered a devastating blow. Too much fresh water. The impact on eggs, sperm, and larvae was deadly. The impact on the economy of Louisiana's oystering communities was equally damaging. About 60 miles southeast of New Orleans is the mostly African-American fishing community of Point à la Hache. Nearly all the oyster boats in the local marina are idle. Byron Enkelade is president of the Louisiana Oystermen Association.
After the spill, went out there and found nothing but dead oysters. This community is dead. It pushed it into poverty like we have never saw before. We have always prided ourselves as being recession-proof in this community. What's the road to recovery? Give us something. We need the facts, regardless of what it is. We need facts. And we need good science.
You know, that's a big question, and that's the question that we're trying to explore.
Sean Powers is professor and chairman of marine sciences at the University of South Alabama. He and his colleague, Megan Schrant, are studying oyster reefs along the Gulf Coast. One of their key missions is to discover why Louisiana oyster reefs haven't recovered. Though this site in Alabama was untouched by the oil spill, it speaks volumes about the ecological importance of oyster reefs.
So oysters, everybody knows, are valuable because people like to eat them. But that's just one of the values that oysters have. Oysters are much more important ecologically than most people understand. One of the things oysters do is they stabilize the shoreline. These oysters will form a protective blanket around the marsh to make sure that wave energy doesn't erode that marsh away. One of the things we know from the Deepwater Horizon in Louisiana was when this habitat was damaged by oil, we saw more erosion of the shoreline. Let's see if we can get the boat closer to the shoreline. Okay.
At a second research site, after first recording the water salinity
it's 23.
23, okay.
and temperature,
29.2.
they randomly mark an area and gather everything living on that part of the reef.
So we're collecting about the top 10 centimeters of material from the oyster reef. So everything that's within a quarter meter square.
All right. We're ready to take our samples back to the lab and process these so we can get good counts of the number of live oysters associated with the oyster reef.
Once back at their laboratory, they sort everything gathered by location, size, and species.
My conclusion is that in 2010, something very bad happened to oyster populations in the central Gulf of Mexico. And that was the big question for me, because once you oil those habitats, then you have a long-term legacy of the spill. Those habitats will take an enormous amount of time to come back, and species that rely on those habitats will be injured for multiple years.
Like most research studies, data is the key to discovery. And as Sean Powers and Megan Schrant continue to gather information, another mystery is unfolding. And it's happening in one of the most isolated places on Earth. The Gulf of Mexico contains a galaxy of tiny animals, some no bigger than a pinhead. Creatures like bacteria, algae, and jellyfish. It's a dazzling display of nature that exists in nearly every ocean of the world. And then there's a phenomenon called marine snow. When these creatures join with other small particles like plants and animal wastes to form sticky flakes slowly drifting downward through the water column. As it descends to the ocean's floor, the marine snow picks up additional particles and grows larger until it becomes a major food source for animals, particularly for those living in the deep ocean. But what does this have to do with the Deepwater Horizon oil spill? In 2010, while millions of gallons of oil poured into the Gulf, something very unexpected happened. Wherever the currents took the oil, gently falling marine snow suddenly turned into a blizzard as it mixed with oil and dispersants. Left behind was an area of oiled sediments about the size of Delaware, covering the floor of the Gulf of Mexico. Research scientists at Texas A&M University in Galveston are investigating the interaction between marine snow, oil, and dispersants. Their first challenge was to create marine snow in the laboratory. Uda Passo is a specialist in biological oceanography.
Marine snow is really important because it's the only way how food gets transported to the deep ocean. Plants can only grow at the surface ocean because only there is some light. And so all the animals living deeper down where it is dark rely on this marine snow to bring food down to them.
Antonetta Quigg is a professor of marine biology. She is the team's lead scientist.
So this is really the first step in making the marine snow. We mix the plankton with the oil, or the oil plus the dispersant, and then we give them 2-3 hours. Sometimes it takes 6 to 7 hours. It's really important in helping us to understand why we saw so much marine snow formed after the spill, something that we haven't seen with other spill events that have occurred around the world.
Like most scientific studies, there are rarely quick or easy answers. Finding the precise link between marine snow, oil, and dispersants and their impact on marine animals will require continued research and collaboration with other scientists. Not very far away, in Panama City, Florida, Dean Grubbs, a world-renowned expert on the ecology of sharks, is preparing for an 18-day research cruise. He is joined by colleagues from Florida State University. The team's mission is to catch deep ocean fish living near the site of the 2010 blowout. Their goal is to create a baseline of information, as well as to discover the long-term impact on fish living in areas covered with oil carried by marine snow.
When everyone realized that the spill occurred at about 5,000 feet deep, the first question folks started asking was, what lives down there? What organisms, what communities are actually being affected by this oil right now? So I updated the schedule.
Dean Grubbs and the vessel's captain go over the itinerary.
So I should get us in before midnight. Sound good?
Yes, sir.
All right.
12 hours later, they reach their first research site.
So we're getting ready to bait up. So on these sets, we set 50 hooks. They range from little tiny 10-aught hooks that take little tiny baits up to 16-aught hooks that take basically the whole side of a carcass. That allows us to basically catch everything from the smallest of sharks up to the largest of sharks, the big snake eels and that kind of thing, all on the same set. Let me know when you're ready, Captain. All right, going over. So we're putting out our largest hooks first. These will be the last ones that we bring in. They're the ones that tend to catch the really big sharks, the 14-foot tiger sharks and 17-foot six-gill sharks and things like that. I think I Got it.
The team puts out a series of baited hooks.
All clear.
About 2 hours later,
We ready?
they're ready to pull in the lines.
Fish on. Whenever we get a fish on, we'll ID the fish. It'll get a specimen number. From there, if it's a shark, then it'll get a temperature taken and blood sampled by Bianca for stress physiology work. And then it'll get measured and weighed. 96. And John will take liver and bile. Those are all the samples that will go for the toxicology work. It's a pretty streamlined process. The ironic thing is we actually tried to get funding to do this exact kind of work to get baseline data in preparation for a spill 3 years prior to the spill. There was no interest. And so we were behind the curve when the spill happened. No one knew what the effects may be or what animals may be affected. And so that's why we actually sample all the way from just a few miles from the spill up to almost 300 miles away from the spill.
Despite the hour, the team continues to set lines,
El Cha.
haul in fish, and collect baseline data and toxicology samples. They will work through the night and into the morning. For oceanographers, these marathon sessions are often a time for reflection.
When I was about 7 years old, I actually caught a little Atlantic sharp-nosed shark, and I told my parents I was going to be a marine biologist. I went through stages where I wanted to be a pro football player and a rock star, but eventually I came back to being a marine biologist, and so that's the career path I chose. Up, see bubbles. Got a critter coming. It's a thing of horror films. That's the king snake eel. They're only found in the Gulf of Mexico. That big king snake eel was only described in 1980. You got it. Fish on. This one's even bigger. Yeah, they're only in the Gulf and mostly only over here where you got the Mississippi River plume and all the sediment from the Mississippi, that silty sediment. That's what they like.
This is Dean Grubb's 15th cruise since the spill.
See Gras, 11-aught.
The information he and his team gather is critical to discovering the long-term impact of oil on the health of deep ocean animals. John Whalen is a PhD student at the University of North Florida.
I'm going to look at molecules in their liver that increase in concentration after exposure to pollutants such as oil-related products.
Bianca Prohaska is a PhD candidate studying biology at Florida State University.
I take the whole blood and I spin it down in this centrifuge, and then I'm able to get the plasma, which separates from the red blood cells. And that's what I'm gonna look at and see what reproductive condition fish are in.
And when all of the samples have been worked up and all the data is logged in, there are still chores to be done. On a small vessel with a limited budget and crew, everyone chips in. No one is excused, no matter how many advanced degrees you have. After going nearly 24 hours nonstop, some team members try to catch a few winks of sleep.
We do keep a pretty intense schedule out here and get maybe 4 hours of, I don't call it sleep because you're on a rolling ship. For folks that aren't used to it, it can be pretty rough on them their very first trip, but your body gets used to it.
What happens next will really test the team's endurance and strength.
Got a big fish, got a big 6-gill shark coming.
Everyone rushes to the stern. It's extremely rare to see a live 6-gilled shark.
I bet she's 1,000 pounds at least. we're gonna test that winch. Somebody hold that a second. She's almost too big for the stretcher.
This is one of the world's largest sharks, and its appearance is similar to fossil sharks, dating back roughly 200 million years.
Go out with the A-frame just a little bit for me. Think they'll hold close. Okay, now up. Real slow, real slow. Keep coming up. Got to do this fast, guys. Okay, hold it, hold it. 1, 2, 3. There we go. Now we're talking. All right, measurement. A lot of people think about the dangers of dealing with these sharks, and there's certainly dangers. Joe, caudal fin has been bitten. A rolling boat, rough seas. You're working with scalpels and hypodermic needles, taking blood samples and bile samples. Working on the deck of a research ship can be quite dangerous. We try to get her in within about 2 to 3 minutes, but they're pretty tough animals.
They say that once you look into the eye of a six-gill, you'll never forget it.
All right, let's get her overboard.
The team is now in a race to get the shark back in the water as soon as possible.
Out with the A-frame. Go ahead and let her down a little bit. Yeah, just about. Down. Okay, hold what you got. Look at her. She's gonna swim right off. Woo-hoo!
For the next 18 days, Dean Grubbs and his crew of scientists will endure harsh weather conditions, lack of sleep, and back-breaking work.
For those of us who are field biologists, this is what we live for, what we work for, all the time spent behind the computer, writing grant proposals, analyzing data, writing papers. We only do that really so we can get out here on the boat and collect data at sea. I think to a normal person, they think we're crazy wanting to come out here and stay up for hours on end on a rolling ship. But this is like space exploration to fish biologists, being able to do work in the deep sea like this and see potentially new species to science and a lot of different species that very few people have ever seen.
After years of gathering information about deep ocean fish, Dean Grubbs is cautiously optimistic.
This has become the largest survey of deep water sharks ever conducted. What we've seen is that the toxicological effects of the oil actually kept ramping up for 2.5 or 3 years after the spill, and then started coming back down. I'm cautiously optimistic that the effects of the spill were relatively short-lived and moderate, but these animals grow so slowly, they reproduce slowly, so it takes a long time for these effects to work their way up the food chain to these really slow-growing animals, and I think it'll take at least 10 years before we're able to see if they're recovering.
Far from the deep waters of the Gulf, thousands of other scientists are working together to fully understand the implications of the oil spill. And this is where their work usually begins, in research laboratories that are centers of innovation. It's where long hours are spent searching for answers and making discoveries. Rachel Hoyer has a PhD in marine biology and fisheries. She does her research at the University of Miami.
Our research group studies the cardiac impacts of oil on the mahi-mahi, especially looking at the heart. And where my research fits in is taking a look at this actual cell to get a better idea of what's going on. We know that there's something that is causing the heart to have problems with oil exposure. And the bottom line of my particular study, looking at the cells, just one cell at a time, is to understand why that's happening, to get a better idea of what mechanism is causing those impacts that we're seeing.
At times, the team's investigation could be a scene out of a science fiction movie. Here we see the still beating heart of a fish isolated from its body. So what do you think? Reality or science fiction? You've probably already guessed, this is cutting-edge science. Georgina Cox is a comparative cardiovascular physiologist and a member of the team studying mahi-mahi.
I measure metrics of cardiovascular function to look at how the heart performs before oil exposure and after oil exposure. What we've done is we've removed the heart from the animal and cannulated the inputs to the heart and the outputs of the heart. So now we've got control of everything going into the heart and everything coming out of the heart. What's going into the heart right now is physiological saline. This simulates the blood that's in the fish. So basically, the heart doesn't know that it's out of the animal. Now we can measure how the heart is doing in terms of cardiovascular performance. We expose fish to concentrations of oil that were actually measured in the Gulf of Mexico during the spill, and then measure cardiovascular function. We've shown that cardiovascular function is compromised due to oil exposure.
The research team also uses a swim tunnel, which is basically a treadmill for fish, to monitor the metabolic rate and swim performance of mahi-mahi exposed to oil. The scientists discovered that when the fish are exposed to oil, they don't swim as well as unexposed animals. Martin Grossell is a professor of marine biology and the team's lead scientist.
We do know that swimming performance is critical for these animals to capture prey, to avoid predation, to perform migrations, and probably also for spawning activities. So the assumption here is that based on what we see in the laboratory with respect to heart function and swim performance would translate to lower success and survival in the wild of these animals. Without this complete understanding, we do not truly know what's going on. We do not truly know what are the most sensitive indicators of impact by an oil exposure.
Thousands of miles from the Gulf of Mexico is the picturesque town of Trondheim, Norway. Here at SINTEF, the Foundation for Scientific and Industrial Research, scientists are collaborating with a team from Johns Hopkins University to develop better ways to ease the impact of future oil spills.
After Deepwater Horizon, I really questioned myself in terms of what did I need to learn in order to be a better responder in the future. So I brought my family here to Norway so that I could gain that expertise and what could I contribute in terms of developing tools and modeling capabilities. The Tower Basin is where we do studies for droplet size, so we can simulate a blowout on a small scale. Our hope is that we can, in real time, be able to monitor and potentially alter the droplet size distribution. And that's important because the droplet size distribution determines how much of the oil stays in the subsurface versus how much reaches the surface.
We learn something new every time we do an experiment. Small droplets are good because they rise slowly. A large droplet will be very buoyant and it'll reach the sea surface quickly. You have a very thick oil slick, which is very difficult in some cases to clean up.
Norwegian scientists are not the only Europeans collaborating on oil spill studies. Less than 1,000 miles to the south, in Germany's second largest city, is the Hamburg University of Technology. Here, scientists, in collaboration with colleagues from the University of South Florida, are also searching for new ways to understand the impact of oil spills. Karen Malone is a master in mechanical engineering. She is focusing on the future, when deep water spills may become more common as Gulf of Mexico oil exploration goes 2 or 3 miles below the surface.
The experiments we're doing here are pretty unique and pretty new to the world of oil spill science because to date, we mainly had spills on the surface or in very shallow waters. This is deep water. So in our experiments, we're replicating the exact environmental conditions we're having down the Gulf of Mexico.
It's like sitting on the floor of the ocean and watching the droplets and bubbles that are rising under these extreme conditions.
This is the first time we have the possibility to replicate this in a lab. and to really find out what is driving these processes.
It's really a miracle that this oil spill brings people together all over the world, independent of the language of the country where they are coming from.
And as new technologies continue to emerge, funding and collaboration between research laboratories becomes much more common. Back along the Gulf Coast, another team of scientists is about to launch an innovative and multifaceted experiment. They are preparing 2 research vessels for a month-long cruise to locations near the site of the 2010 oil spill. Their goal is to test new equipment designed to predict where the wind, waves, and currents of the Gulf would take surface oil after a major blowout. If successful, the information could improve the response to future oil spills, saving the coastal marshes or even the Barataria Bay dolphins from further harm. Eric DeSaro is the chief scientist on the cruise.
Oh, yeah, okay. It's a little crazy, but you know, we've done this a lot of times. It'll just happen. People are all working at their sort of pace, their problems, and then they try to solve them. I'm not terribly worried about it.
We got a lot of different teams coming together here at the last day. Everybody's here from University of Washington, British Columbia, Scripps.
The purpose of our cruise is to look at how oil might spread in a future oil spill, so where it goes, because that really matters. People care whether it goes to where they are, and so knowing where it goes is a big deal, because if you don't know where the oil is going to go, then it's hard to prepare people and set up the cleanup, things like that.
Tamayos Gokman is responsible for the entire operation.
It took us an entire year to prepare for this cruise, mainly because we didn't have the equipment needed to carry out the measurements.
The team has brought with them a new generation of a device called a drifter, a mechanism that floats with ocean currents while transmitting data like location, speed, and water temperature.
This is a really, really great chance for us to push science forward. If you don't have science to help you make quantitative decisions, then you have to essentially guess. A lot of things can go wrong. Probably the biggest problem is weather.
And that is exactly what happens.
You've got this huge mass of weather in the Gulf. We'll probably have gale force winds for a time, so don't even think about boating tomorrow morning.
By the time the 2 research vessels reach their drifter deployment site, the weather has turned.
We've been deciding what to do about the weather, and we're not going to risk it because there's too much potential for damaging equipment. Meanwhile, we can get some of our equipment tested and then just wait.
But then some good news. The weather forecast changes. By sunrise, the seas will be much calmer. The team seizes the opportunity and starts assembling the drifters for a morning deployment. Brian Haus specializes in the use of satellites to track ocean currents.
These contain a GPS on this board. So every 5 minutes, it'll update its position to the satellite, which will send the data back to our server at the University of Miami. In the end, we're going to have to build 200 drifters. The other boat is going to be building 800.
The work continues through the night, even during times of heavy wind and rain. And when the team does take a break, it's not long before they're called back to work.
Okay, back deck boys, 5 minutes till liftoff.
Squall's coming through, so it's gonna be wet on the deck. Not the most comfortable, but it's workable.
By morning, the skies are clear, but the seas are still rough. deploying the drifters is still on hold. At an airport near Gulf Shores, Alabama, other members of the team are preparing to provide logistical support.
There's no problem for us to fly today and get outside of that and work down there?
We will fly. The plan is to fly. I look outside, how can you not fly on a day like this? There's great science to be had.
Jack Edwards traffic, Port Navia 32 kilo, departing runway 17, moving out to the south. Jack Edwards.
So the boats are on their way, they're ready to do their large-scale deployment. What we are trying to do is give them a heads up on how the ocean looks like in that area.
2 hours later, they fly over the research vessels and send an updated sea surface report. Though the seas are still rough, they've calmed enough to deploy the drifters.
First drifter deployment now.
And go!
One of many.
Okay, deploy drifter number 2.
All right, and go!
230.
Go. We're throwing out drifters, so it's going well. We just gotta keep going. It's a marathon, not a race.
7, deploy.
Deployed.
I'm keeping track of when we're throwing the drifters in the water.
221, gone.
I put down the drifter number, the waypoint number, the time we dropped it, and the GPS location. So that we have some record as to when the drifters were launched. And go!
222.
32. All right, last one.
During the month-long cruise, the research team deployed over 1,000 drifters. Assisted by a wide variety of communication and data gathering tools, it's an experiment on a scale that has never been done before. The initial results are remarkable. Real-time visualizations of ocean currents that will ultimately lead to computer models that will help predict the movement of oil during future spills. When all the information is analyzed and programmed, this unprecedented experiment will enhance our knowledge of ocean observations for years to come. Today, the scientific community is working together to push the boundaries of what they've learned about oil spills and what still needs to be discovered. Their efforts represent one of the most remarkable collaborations in the history of marine science.
We're learning a lot more about what happened to the oil, how much damage did it do, and its lingering effects on the environment.
The language of the biologist is slightly different from that of the chemist, and so we've had to come together and learn how to interact and work together.
We realized that we needed physical oceanographers to tell us where the oil was going. We needed biologists to tell us what the response of the animals were. We needed socioeconomists to tell us what the public perception of it was and what the economic impacts of the damages that we were seeing.
It's been a great collaborative enterprise. We have dozens of scientists all trying to solve the same problems and all sharing in a way that I've never experienced before in my career.
In the end, there are no easy answers, no quick fixes. This presents both industry and the scientific community with an enormous challenge: the need to work together to strike the right balance between the search for new sources of energy and what nature can safely provide. Though separated by distance and culture, for the more than 7 billion people who draw sustenance from the resources of the world, there are common bonds. Bonds that are renewed by each generation bringing new ideas, new attitudes, new hope. Planet Earth. This is our home. This is where our journey of discovery must begin.
I grew up on the Gulf Coast and spent a great deal of time on the beach watching wild dolphins swim by. So that's really where the inspiration started.
I was fortunate enough to take a lot of trips to the beach when I was a kid, and my parents couldn't keep me out of the water or away from anything that moved in the water. So I've always sort of been interested in marine life in general.
I was raised in a very rural area, very close to a pond, and I spent most of my waking hours in that pond, netting out any aquatic organism I could get my hands on. And was always fascinated by the ability of these animals to live in an environment, the water, where we cannot survive.
Far back as I can remember, I've always been really interested in animals, and I love the outdoors. I always went camping when I was little.
The reason I got interested in science to begin with was because of the US space program and Star Trek. Spock died, I was so sad.
Funding for Journey to Planet Earth was provided by a generous grant from the Gulf of Mexico Research Initiative, scientists investigating impacts of oil and dispersants on the Gulf of Mexico ecosystem.